So, hello students. In this revision session, we'll talk about simultaneous equations and different methods of solving simultaneous equations. Okay, let's come to the first example. Now, under solving, with regard to solving simultaneous equations, there are different methods. Okay, that is, there are three algebraic methods and there is one graphical method. Algebraic methods we've already discussed. Graphical methods we are yet to solve. We are yet to see, learn about it. Okay. Let's start off with the first problem. Okay. So this is a simple example, and it's a very basic method. It's one of the first methods that you have learned, isn't it? So this is solve for x and y by substitution method. So I told you very clearly that no matter what be the nature of the equation, that is the nature of the coefficients, constants, and so on, you can use any method. It's not like you have to use a particular method. Okay, there is no the method to solve. There are different ways. It's only that the feasibility. Like I told you, when the coefficients are relatively smaller, you'll go with substitution. When they are considerably larger, you can go with elimination. And in cases where the coefficients are swapped, we have special elimination. That too we have discussed. And RCM is also there. Cross multiplication, RCM, rule of cross multiplication. But then in an examination or in a unit test, when the question specifies the method, you have to go with the question. That is, you will lose marks if you don't get to the, arrive at the solution by the required method, by the mandated method. So you might get the answer correctly, perfectly. You might have performed elimination instead of substitution. But if the question mandates substitution method, you have to show substitution. So later you will not get the required marks. So go with it. So it's always better to learn all the three methods, okay? Because you'll not know which question can ask you for a particular method. Now let's start off with the solution part of this. So it is 2x plus 3y is equal to 13, and you can call it as equation 1. And then you have x minus 2y is equal to negative 4, which is equation 2. So two simple equations. We have to solve for x and y. Now, we are going to use substitution. The question is telling us to use substitution. And even otherwise, I would have really gone with substitution for the simple reason that if you look at equation 2, okay, I'll just show you the marker. Yeah, see, the coefficient of x here is what? The coefficient of x here is 1, isn't it? If you look at equation 2. So because the coefficient of x here is 1, because small numbers are involved, small coefficients, I would rather go with elimination, substitution method, and that's what we will do. So the second equation that you're taking it as, you're considering that equation first. So second equation, so x minus 2y is 4, or x is equal to minus 4 plus 2y. So you looked at equation 2. From there, you're rewriting x in terms of y. X is minus 4 plus 2y. This. Okay, I'll just put that in a box. Now that value of x, that is your expressed x in terms of y, you're substituting for x in terms of y, that you're going to put it in your equation 1. This equation, I'll write it down here. So what is that? 2x plus 3y is equal to 13. Why did I choose second equation? Because the coefficients are small. Well, even in equation 1, coefficient of x is there, small, 2. But then when you look at equation 2, you have an even smaller coefficient of x, which is 1, isn't it? See, if I look at equation 2, it is 1. Coefficient is 1. When nothing is mentioned, it is 1 here. Okay. So now from equation 2, I have substituted for x, and I'm going to put that in equation 1. This is my equation 1. 2x plus 3y is equal to 13. I just rewrote it here. And now what's my next step? I'm going to rewrite for x in terms of y. So x is like a box, isn't it? That box what I put here. That I'm going to put it here. So I'm going to substitute for x. So instead of x, I'll put minus 4x into minus 4 plus 2y plus 3y is equal to 13. And now what do I get? I have got an equation solely in terms of y. It is similar to what you learned in grade 8. What did you learn in grade 8? An equation in terms of only one variable, isn't it? Simple linear equations in one variable. So it's now you have an equation entirely in y. So let's open the bracket. 2 into minus 4 is minus 8. 2 into 2y, it is 4y plus 3y is equal to 13. Let me just come down. So it is, now you have to solve, isn't it? Just club the like terms together. 4y plus 3y is 7y. 7y is 13 plus 8. You carry the minus 8 over to the other side. So 7y is equal to 13 plus 8 is what? It is 21. Or y is 21 over 7, which is 3. So now we got what is y. So see, once we get one variable, it becomes the value of one variable, it becomes very easy. Now it's your choice. You can substitute in equation 1 or equation 2. Let's say I'll go with equation 2 because the coefficients are smaller and it's better to choose that, isn't it, when you substitute, because you'll have less smaller numbers to compute. So 1x minus 2y is equal to negative 4. So 1x minus 2 into, now that I know y, I'm going to put the value of y here. 2 into 3 is equal to negative 4. X minus 6 is equal to negative 4, or x is equal to 6 minus 4, which is 2. I got x is 2. Okay. So I got x is 2 and y is 3. Now, how am I so sure that my equations are right? So now you don't have to do it in the unit test, but I'm just telling you that if you do have time, it's a good practice to verify if you want to, and only if you have time. See, look here. This right here, verification. See, 2x plus 3y is equal to, you can choose any equation again. And what did I get? I got x as 2, isn't it? So 2 into 2 plus 3 into 3. So I have to check this is the left hand side of the equation. 2 2s are 4, 3 3s are 9. Yes, I'm getting 13. I'm getting LHS equal to right hand side. Left hand side equal to right hand side. And so the equation is satisfied. Even if you put it in the second equation, x minus 2y. Okay, 2 minus 2 into 3, 6. 2 minus 6 will give you minus 4, which is equal to right hand side. So this is what we have done. We have taken the second equation because the coefficient of x is 1. So very small coefficient. You rewrote x in terms of y, and then you took in equation 1, you substituted that value of x. So instead of x, you're writing x as minus 4 plus 2y. Okay, so you rearrange the equation 2, you wrote x in terms of y, you got this, and finally you in equation 2 is modified now so that you get an equation entirely in y. You solve for y, look down. So when we solve for y, we clubbed the like terms, we solve for y, we got y is 21 over 7, which is 3. Now that I know the value of 3, you can substitute 3 in equation 1 or equation 2. The choice is yours, and you will get the corresponding value of x. In this case, I substituted the value of y in equation 1, equation 2 rather. 1 into x minus 2y is negative 4. 1 into x minus 2 into 3 is negative 4. So x minus 6 is negative 4, or x is equal to plus 6. That is minus 6 goes over to the other side as plus 6, and 6 minus 4 is 2. Hence we get x is 2. Okay. So this is a method where I have shown you how to solve a system of equations using substitution method. Again, please remember it is very suitable. It is most suitable when the coefficients are smaller. Okay, let's move on. I'll just take you through another equation and another method of solving. Okay, so again, there's no really hard and fast rule. You could have used elimination for this particular problem, which I just showed you in substitution as well. Okay, I'll just show you another problem here using elimination method. All right, let's take down this problem. Okay. Okay. So using elimination method, again, as I told you, go with the method that is specified in the question, because that is very important. That's why you should know all the three methods. And then if nothing is specified, you can use your decision. You can make up your mind and you can decide which method you want to. But again, you have to judiciously do it, isn't it? Because If you're going to have large coefficients, no point in using substitution. Then maybe RCM or elimination will come into the picture. So we look into RCM, elimination now. Okay. So solve for x and y using elimination. Equation 1, 2x plus 3y is equal to 6. Call it as equation 1. Equation 2, 6x minus 5y is equal to 4. We always going to number the equation so that when we refer to it, you will know. So when you are mentioning the steps, what have you done to equation 1? What is the transformation? What have you multiplied with? So it's always good to name the equation beforehand. So I have two equations. Now elimination method. So in elimination, you decide what variable you want to eliminate. Isn't it? You want to get rid of that variable. So whichever you can decide to eliminate x, or you can decide to eliminate y. If you decide to eliminate, let's say x, then in across both the equations, that is equation 1 and equation 2, you have to ensure that the coefficients of x are the same. Okay. And if you want to eliminate y, the same thing. You have to ensure that across both the equations, the coefficients of y are the same. So whichever variable you want to eliminate, see to it that its coefficients are identical across both the equations. In what sense identical? Now, let's say I want to eliminate x. Okay, it's a good choice. Now I want to eliminate x here because now look at the coefficient of x in equation 1. Coefficient is 2. Look at the coefficient of x in equation 2. It is 6. So in equation 1, the coefficient of x is 2. In equation 2, the coefficient of x is 6. So what I can do is, now I can take the LCM of 2 and 6. And that's what I need to do. So LCM of 2 and 6. Why am I taking the LCM? I want to make the coefficients identical. So LCM of 2 and 6 is 6 only, because 2 goes exactly into 6 3 times. So all you have to do is you have to ensure that you have the coefficient as 6 across both equation 1 and 2 as the coefficients of x. Yeah? The coefficient of x should be 6. Equation 2, no problem, because already you have the coefficient of x as 6. But in equation 1, the coefficient of x is not 6, it is 2. So I need to change it. I need to make it 6. How do I make it? Just by multiplying that 2x by 3? No. So I need to multiply the entire equation to okay, the entire equation to, I need to multiply it with 3. So that 2 into 3 will give me 6 as the coefficient of x in equation 1. So the entire equation 1 has to be multiplied with 3, not equation 2. It's equation, because in equation 2 you already have the coefficient as 6. So you have to multiply the entire equation 1 by 3. 2 3s are 6. All right. That's what we'll do here. Wait. So when you multiply equation 1 into 3, look what happens. When you multiply equation 1 into 3, so 2 3s are 6, 3 3s are 9, 6 3s are 18. I'll get that. So 2 3s are 6x, 3 3s are 9y is equal to 6 3s are 18. Maybe since I've modified it, I've transformed it now, I'll call it as equation 3. So you can keep on naming the equations. Whenever you get newer equations by suitable transformation, just keep naming them accordingly. Now below this, you can put your equation 2. What is that? 6x minus 5y is equal to 4. Okay. So now I have achieved what I wanted. I have made the coefficients of x the same across both equation 1 and equation 2. Equation 2, no need, because already the coefficient is 6. But in equation 1, the coefficient is 2. I multiplied entire equation by 1 to get 6 there in that place. Okay. Okay, now next what do I do? So I can do equation 3 minus equation 2. So I'm subtracting. Why do I have to subtract? I want to get rid of. That is the whole idea of elimination, isn't it? I want to get rid of. I want to eliminate x. So what happens? I'll do minus. When I'm doing minus, the signs will change. So I'll get what? See here. Yeah. 6 minus 6 is 0. 9 plus 5 is 14. 14y. And then 18 minus 4 is 14. So I get 14y is equal to 14, or y is equal to 1. Now that I got y is 1, It's your choice. You can substitute in either equation 1 or equation 2 to get the value of x. I will go with 1 again, the same story, because coefficients are smaller in equation 1. So in equation 1, 2x plus 3y is equal to 6. So I'll put 2x. I don't know what is x. 3 into y. 3 into 1 is equal to 6. 2x is equal to 6 minus 3. This 3 goes there. 3 ones are 3, no? So 2x is equal to 3, or x is equal to 3 upon 2. Wait, I'll just write it a bit properly. So I get what? X is equal to 3 upon 2. And of course, you can just put them in a box because it is the final answer, and y is equal to 1. I can always cross check. Not really need it, but if you want to. So if you want to look at equation 2, 6x minus 5y, isn't it? 6x minus 5y is equal to 4 I need to get. So let me just look at the LHS on the left hand side. So 6 into x is 3 by 2 minus 5 into 1. That will be 2 1s are 2 3s are 3 3s are 9 minus 5, which is 4, which is equal to the right hand side. It satisfies the equation. Okay. So it is, we have solved this using elimination. All right. You have to look at the coefficients. You have to see that you get the LCM of the coefficients and make sure that both the coefficients or across both the equations, whichever variable you want to eliminate, the coefficients have to be of the LCM. Yeah. In this case, LCM of 2 and 6 is 6. You already have 6 in equation 2, that is 6 as the coefficient of x. You just have to take care of equation 1. Okay. Now what if I want to eliminate y? I'll show you now the same problem. I will just rewrite this, the same problem. In the next step, I'll just show you this where I'm trying to eliminate y. That is the same problem, but I'm going to use a technique where I'll try to eliminate y and not x. We should get the same answer, isn't it? The method, regardless of the method, regardless of which variable you want to eliminate, we should get the same answer, same value for x and y. Okay, so I'll show you the other method of elimination. I mean to say when I'm trying to eliminate y. So the same thing, let us take equation 1, name them. 2x plus 3y is 6, 6x minus 5y is equal to 4, and then call them as equation 1 and equation 2. So I want to solve them using elimination. However, now I want to eliminate y. So whichever whichever variable I want to eliminate, I have to ensure that you have the same coefficients across both the equations for that variable. So forget the signs, forget positive, negative. You just look at the numerical value. You have 3 and 5, isn't it? And the LCM of 3 and 5, as we know, it is 15. So I have to get 15 as the coefficient for both the equations as the coefficient of y. See, here you have 3 and here you have 5. So how do I go from 3 to 15? 3 into 5, and 5 to 15, 5 into 3. Which means equation 1, you will be multiplying it with 5. So that 3 5s are 15. And equation 2, you will be multiplying it with 3 because 5 3s are 15. Okay. So we have to ensure that we suitably multiply so that we get the coefficient as the LCM in this case. So now what is it? 2 into 5 is 2 into 5, then 3 into 5 and 6 into 5. Similarly, 6 into 3, 5 into minus 5 into 3 and 4 into 3. We'll do it. So now what happens? Equations are getting modified. So 2 into 5 is 10. 10x. 3 into 5 is 15y is equal to 30. And I modified it, call it as equation 3. Then likewise, equation 2 also I'm multiplying it. Equation 2 I'm multiplying it by 3. So 6 3s are 18x minus 15y. 4 3s are 12. Call it as equation 4. Okay. And now what do I have to do? I need to add. Why am I adding? In the previous method, that is an elimination itself. But when I try to eliminate x, when I try to eliminate x, What did I do? I added them. If you just scroll back, I did subtraction, not added them. I did subtraction because I had 6x and 6x. Both were positive 6x, isn't it? Then we have to subtraction to eliminate. But now I have plus 15y and minus 15y. So if I simply add them, it's sufficient because minus 15 and plus 15 will get nullified. So addition operation is enough here. So now we'll do addition. 10 plus 8 is 10 plus 18 is 28. Okay, so it will be 28x. All right. The 0 is equal to 42, or x is equal to what? 42 upon 28. Now we are able to relate this to our 14 tables, isn't it? 14 3s are 42, 14 2s are 28. So it is 3 by 2. It's exactly what I got earlier, isn't it? Now x is equal to 3 by 2. And now the choice is yours. Take any of the small equations. I'll take the first equation, that is 2x plus 3y is equal to 6, and you can substitute for x as 3 by 2. You'll get the corresponding value of y. We'll do that. 2 into 3 by 2 plus 3y is equal to 6. 2 and 2 will cancel. 3 plus 3y is equal to 6, or 3y is equal to 6 minus 3, which is 3, or simply y is equal to 1. That's exactly what we got earlier, isn't it? So y is equal to 1 and x is equal to 3 by 2. All right. Okay. Let's look at some special elimination. I think it's time to look at some special elimination. I've discussed this in class as well. I'm spitting it out here again for revision. Let's take up this. Okay. Okay. Here's the sum, which states like solve for x and y. 15x plus 23y is equal to 53, and 23x plus 15y is 61. What do you see here? If you look closely, now your substitution, your normal elimination, your what do you say? That is equating coefficients. It's not going to hold good here. Okay, it's not going to help you in any way here because you're going to get huge. I'm not saying no. I'm not saying a total no. It's going to be very cumbersome, huge coefficients. See, when we have a simpler technique or a strategy, let's learn and use it. So you see here, the coefficients are swapped. Coefficient of x is 15. Here the coefficient of y is 15. See, swapped. Now if you look at y, coefficient of y is 23. Coefficient of x is 23. Coefficients are swapped. Okay, so you see that here. So now what I can do is, in this case, I'll use a technique called special elimination. I'll number my equations. Equation 1, equation 2. The technique is very simple. You don't have to go for LCM or substituting or any of that sort, or finding LCM and equating coefficients. Simply add equation 1 and 2. The technique is add and then subtract. That's it. Yeah, add. The buzzword is add. First add, then subtract. Let's add. Then add, what do I get? 15 plus 23, 5 plus 3, 8, 2 plus 1, 3, 38x plus 38y. 3 plus 1, 4, 5 plus 6, 11. Now, let me see. Let's see. 3 8s are 24, right? What is 38 into 3? 8 3s are 4, 29, 10, 11. See? So I can take out 38 common. 38 into x plus y is equal to 114. All right. So 38 into what will give you 114? 38 into 3. 38 ones are 38 3s are. So x plus y is equal to 3. Now by adding and taking out common factor of 38, I've got a simpler equation saying x plus y is 3. Call it as equation number 3. I've just simply added them. Now I cannot use it for any just about any equation like that when it says elimination. It's because the coefficients are swapped. Okay. Next, what do I do? Next, I have to subtract them. I'll just rewrite the same equations now again, and I will perform subtraction. So 15x plus 23y is equal to 53. 15x plus 23y is equal to 53. And what's the other one? 23x 23x plus 15y is equal to 61. All right. So that's my same old equations 1 and 2. Earlier I added them. After adding, I got 38x plus 38y is 114. I took out 38 as a common factor, and after suitably cancelling, I got x plus y is equal to 3. And I call it as equation 3. Now the same thing, I'm going to perform subtraction. And I'm going to get another simpler equation. See, subtraction. Doing subtraction, change the signs. 15 minus 23 is negative 8x. 23 minus 15 is plus 8y. And 53 minus 61. That is, you are going to get negative 8 again. Or simply, if you divide this entire equation by 8 or take out 8 as a common factor, you will get what? Minus x plus 1y, or simply y is equal to minus 1. That is equation 4. Okay. So, just like in equation 3, we got it by taking out 38 as a common factor. Here, by taking out 8 as a common factor, we got equation 4. Now, just consider equation 3 and 4. X plus y is equal to what? 3. X plus y is equal to 3. And equation 4 is minus x plus y is equal to minus. I'm just writing them together so that we can visualize what next to be done. All right. Now, so x plus y is 3 minus x plus y is negative 1. Simply add them. When you add them, what happens? X will get eliminated. So we get 2y is equal to 3 minus 1 is 2, or y is equal to 1. And then when y is 1, just check. You can put it in equation 3. Don't go with equation 1 and 2. They are big numbers. If you look at equation 3, you put y is 1, x plus 1 is 3, giving me x is equal to 2. Okay. This is what we obtain. X is 1 and y is, x is 2 and y is 1. All right. Now, if you just want to check whether, oh, is it going to hold good? Look at any of the equations. Let me take the first equation. 15x plus 23y is 53. 15x plus 23y is 53. If you're just going to consider the left-hand side, 15x is 2, no. After solving, we have got what? X is 2 and y is what? 23 into y is 1. Into the 30 plus 23. It is 53. See, indeed. So, not required. See, I'm showing you the verification here. You don't have to show it in the unit test. It's just for you to cross-check. And in case you think that you've gone wrong, when you substitute, if you're going to get the LHS being equal to, or if the equation is satisfied, we say when LHS is equal to RHS, you're sure that what you did is right. Okay. I stop for here and come back with more content in the next session.